Welcome to Module 4, Unit 8, Lesson 5. Today we're going to multiply binomials to find the y-intercept. So let's take a look at the opening exercise. Marshall had the quadratic function y equals x minus 2 quantity squared plus 0. All right, can you guys easily tell what the vertex would be? Because this is vertex form. Back in lesson 3, we talked about different forms which were helpful for different things. Vertex form is obviously very helpful to find the vertex. All right, so we can tell the vertex right away by looking at it, and it would be 2, 0. There, really handy, right? We just used this number and that number. Now, Sarah said that Marshall could find the y-intercept if he wrote his equation into standard form. So we're going to start looking at standard form here. All right, that's where all the parentheses are down, and we've got ax squared plus bx plus c. So this is what they did. See the square right here, that little square? That means x minus 2 times x minus 2, which is exactly what they did here, right? That's it. Now, they are very correct when they say they can do it. The only problem is Marshall doesn't know how to actually multiply these binomials. This is called a binomial. There's two parts to it, two terms, right? So we're going to learn today how to multiply binomials. Let's go to the next page. Here we go. This is kind of fun. I think you're going to like it. So this looks kind of complicated, and there's some weird arrows on here. But if watch, I'm going to just use some white out here, okay? Just think of this as, if I just had this x in front, don't you know how to multiply this already? This would be like x times x minus 2. Isn't that what they did? Right? Here's the x times x minus 2. All right, well, we really do have that number underneath here. So we're going to do the first part, and then we're going to take away this x. Look at this. Pretend it wasn't here. And wouldn't you then distribute the negative 2 times x minus 2? So what we're doing is we're just distributing 2 times. We're just going to do it one part at a time. Okay, so don't get overwhelmed. Let's give it a try. So here we go. We have x minus x, which is x squared. And x times a negative 2, that's a negative 2x. All right, now let's try the next part. A negative 2 times x is negative 2x. A negative 2 times a negative 2 is a positive 4. So that is our final answer, almost. If you notice below, we have a few blank spots. They only gave us 3. And that's because we aren't actually going to write it in terms of 4. Can't we combine these two? Yeah, we can simplify that a little bit. So we would have x squared. We'd have plus 4 at the end. And our b term, a negative 2x minus 2x is negative 4x. And that is in standard form now. Look, we have an a term, a b term, and a c term. And the whole advantage to this is, look what we have. Do you remember what we get from standard form? We get the y-intercept. All right, so there's 3 different forms, and each one kind of has its pros and cons, things that it's good for. Okay, so this distribution process continues by multiplying them. Use the space above. We did this. This is great. And now we have, look at this, we have a trinomial. 3 terms, it's called a trinomial. All right, and that's also in standard form. So that's ax squared plus bx plus c, standard form. All right, so let's take a look at number 3. What is the y-intercept for Marshall's quadratic? Oh, it's that 4, isn't it? 0, 4. And I got that from right there. All right. Another way to write it is, I like the way we wrote it. I think it's great. Okay, so number 4, it says use the vertex and the y-intercept. This is why we went to all this work, to graph a parabola. So 0, 4 is my y-intercept. And if I look back up, the vertex from the previous page was 2, 0. That was our vertex from the last page. So I'm going to graph 2, 0. Look at that. All right, and if that's on our line of symmetry, the vertex is always on the line of symmetry, then couldn't I just reflect this over on the other side to get a second point? Look right there. And with 3 points, that is enough to be able to graph. So look, I could graph that parabola. There it is. It's probably not perfect, but hey, it's pretty close. All right, so that's how you multiply binomials. There's another way that I'm going to show you because they use this a lot. It's called the area method, the box method. They use this a lot for higher up concepts. And so they want us to kind of show you this. What's nice about this is that it's really handy to keep your work organized. And students that use this method a lot of times catch little mistakes. So let's take a look. Gisela computed the number 342 by 23. She broke up the 342. Have you guys ever done this in elementary school? Right? And then they were able to kind of multiply those bigger numbers a little easier. All right, and then if you notice, look, they added up the diagonals to get 800 plus 900 is 1700. 40 plus 120 gets you 160. We're going to do the same thing. Here we go. Bobby said that Gisela's method could be used in algebra to multiply other polynomials. Here he wrote the following. So let's try it. All right, the area method just means length times width, doesn't it? So let's try for this box right here. All right, if the length is 2 and the width is 2x, wouldn't the area be 4x? So you're just doing length times width. All right, 2 by 3 is 6. Let's try this square right here. What would that one be? That'd be 4 times 2 is 8. Don't forget, x times x is x squared. All right, let's do this one down here. You should get 12x. All right, how about square A? Should have gotten 6x cubed. And then D would give you 9x squared. Ta-da! Now, just like they did above, how they kind of added the diagonals, we're going to do the same thing. All right, we can add these diagonals and those diagonals. So I would get 17x squared. See how they're like terms? And this would be 16x. Those would be like terms. There's no other like terms to combine. So my final answer would be 6x cubed plus 17x squared. Do you notice I'm writing this in descending order? Plus 16x and plus 6. Don't forget descending order. You start with the largest exponent and work your way down to the smallest. Okay? And we've already combined like terms. So that's like the whole rest of the page. We just did it in the box, right? We even combined them already. So look right here at the bottom. Both models were area models, right? Or you can double distribute. It works the same way. All right. So right here, they took x minus 1. They put the x here, the minus 1 here. This one, x plus 2 is x and a positive 2. So if we fill it in, you'd get a negative 1x. And over here, it'd be 2x. Combine those. You should get x squared plus 1x, or I would just write x, and then minus 2. And what's helpful about this? What is our C term? That's our y-intercept. Okay. Another way to find y is you could always plug in zeros for x. Yeah. You could take your equation and just plug in zeros. Remember when we set them equal to 0? All right, so what is